Okay, well, good afternoon. I'm Robin Minturn, Supervising Counsel for Supply and Trading, and it is my great honor today to introduce you to Mike Ciannilli. He's Program Manager of NASA's Apollo Challenger Columbia Lessons Learned program. Back in 2016, Mike started this program to share the difficult lessons that NASA has learned to ensure that there is future mission success. He works with numerous governmental, private, academic, and international organizations, and he's here today to share NASA's difficult lessons learned during these disasters. And I really invite you to think about how we can learn from those lessons learned and how we can apply it here at Chevron. We are going to have a Q&A session after his presentation. For those of you participating on Teams, please go ahead and use the chat function. We do have someone here in the audience who will be reading those questions. And without further ado, I'd like to introduce Mike.
Thank you. Thank you, Robin, and thank you, Lisa, and everyone that invited me here today. So thank you, appreciate that a lot. Also appreciate the hospitality. We had some great food, great hospitality, and you cranked up the heat for me, so I feel like Florida. Florida on steroids, actually. So everything's bigger in Texas. Well, your thermometers are bigger. I can prove that. So I'm going to go back and cool off a little bit tomorrow. But anyhow, again, thank you for that very, very much. I have to say also, it was a little intimidating coming here for a legal group of gathering of folks. Usually I'm talking to engineers and scientists. They don't really communicate too well. They're kind of like looking at their shoes all day long. So we don't talk very eloquently. Our biggest words are like go and no go. And pretty much that covers a good day and a bad day. So I was trying to think of how to open up remarks to folks that are a little more verbose. Right? Lawyers are more verbose, right? You guys talk a little more eloquently and opening arguments and all that sort of thing. So I actually went to Google to figure out how to do that. Not a good idea, but all I typed in was appropriate opening remarks for a legal conference. Right? That was my intention to get that. Hit the search button, hit the button, came back with top 10 jokes of lawyers. I read the first two, and my sage advice from my legal counsel, do not repeat any of them. So hopefully we'll stay on the same side for all this. So again, thank you so much for spending time with me today. We're going to talk a little bit. It's going to sound like a history conversation. I am not a history professor. I don't claim to be one. I'm not trying to be one. It's going to sound like that, but I really invite you and ask you, as I go through these events and our history at NASA, look at your events of today, because this is really a conversation about today and tomorrow. Again, we're going to go back 50-something years in one case, but it's really not about that. And I tell our young engineers at NASA when they're coming on board, we're not repeating our stories just to hear ourselves or what happened back in the day. It's really about tomorrow, because we can repeat these same mistakes over and over again, and you'll see in cases we did that with high prices and sacrifice of people's lives. We don't want to do that again. So after the shuttle program was closed in 2011, we started looking at what do we do next. We had over 7,000 people at Kennedy Space Center alone get walked out the door. That was tough for us. With those 7,000 people went millions of man-hours of knowledge that was built up over Mercury, Gemini, Apollo, and 30 years of space shuttle. All the whys of what you do, not just what buttons to push and what to do, but the essence of why you do what you're doing. That walked out the door. That was very, very scary. So one of the things we did is start this program called the Apollo Challenger Columbia Lessons Learned program, with a real emphasis of refocusing on the past and being very frank about that. What really happened? How do we get into these fixes? Not just the technical, but the psychological reasons how we got into some of these missteps. So the folks that are coming behind us, which are probably smarter than we'll ever be, how can they take some of that hard-fought and learned wisdom and apply that to their knowledge and go farther and further than what we've done? So that's the purpose of the program. We're taking it all over the country. So thank you for having the interest to do that. We're proud to do that. Thank you for what you all do. You provide energy for the nation. That's a wonderful thing, right? I couldn't have gotten here. I can't get to work every day. I can't watch television at night without all what you do. So thank you for the products and services that you provide for the nation. We want you to be successful. So that's, again, what we're here for, do that. The moniker of the program goes back to Winston Churchill. Those who fail to learn from history are doomed to repeat it. That's happened over and over again, right? Everyone from an intuitive teenager knows that to wise generals. You know, if you repeat those same mistakes, it's going to happen. If you don't learn, it's going to go over and over again. Well, you're going to see, we're going to step through some things that's going to talk about how we did that unintentionally. We bring this program in different ways, so this is our first introduction to Chevron, but we have podcasts, we have work with book authors, we work with a movie project. We're actually working now with 2 TV shows, do a lot of virtual presentations and in-person speaking. Every way we can get this message out to as many people around the world as we can, we're trying to do that. So it's an open, collaborative environment. If I can ever be of help, please reach out. We're here to do that. There's lots of missions. We've got thousands of missions at NASA. Here's some missions where things came really close. Some things were not very good at the end results. Every mission, we have something learned. But it's not always bad things. Sometimes there's good things. In our business, when something goes right, we're so excited to get to the next T0 and the next launch, sometimes we skip over what happened. Some cases, we got lucky. Right? We didn't realize how close we came. In some cases, we did a new process, works even better. So we try to do a lot of post-test briefings. You know, why did this mission work so well? Or why didn't that work so well? And try to employ that. So again, we're going to focus more on things that didn't work well, but please remember, you can learn as much from the good times as well. The why is what we try to really emphasize to our folks. Again, I could bring launch manuals in here. I probably need a cargo plane to bring all the manuals we have to launch the vehicles and process them. There are tons of books. A high school student can run the countdown. It's not that complicated if you follow the steps. What we get paid for is when things don't work right and understanding why you do what you do. That's the essence of that. Why are you telling them to do this? Why are you holding now? Why are you doing that? Some of it's knowledge built, and some of it's just the seat of your pants and in your gut. That's the stuff we can't forget, and that's why we don't want to do that. So as you go through this, some things may remind you of conversations you've had recently, or you may be having tomorrow or the next days. Please never forget your why. We call it the compass for our young folks. That's your compass. When you're in those meetings and you feel this pressure coming from all sides, and maybe your boss's boss's boss is in the room, right? And nobody wants to bring bad news to the boss, right? When you have to get out of that chair and say, in our case, no go for launch, you're going to get a lot of attention. There's a lot more lights than this in that room, it feels like. It feels like 200 degrees in that room and your knees are knocking, but you have to do that. But everybody faces that at times. Hopefully not too often, but you do. So that why will remind yourself of getting out of that seat. Why am I going to take that chance? I might feel like I'm going to lose my job, lose my credibility. I could be wrong. Nobody wants to do any of those things. But I have a lot of people that I can tell you that wish they had made different decisions each of these flights because they live with consequences of losing a crew. So we're going to go back, and this is going to be a fly-through history, so I'm going to go through quick, otherwise we'd be here for all day long, and then Robin will have to buy us dinner, so we don't want to do that. So we're going to keep going through a kind of quick pace, but I'm going to show you some highlights of each of these missions. Early on, this was our first taste with disaster. So, but setting the stage, 1961, first American in space. Space race is off and running. Alan Shepard goes up. Project Mercury starts. John Glenn follows him. And we're off to the races. Finish out Mercury, go into Gemini. We're moving fast because President Kennedy told us you're going to get to the moon and bring folks home by the end of the decade. Kind of crazy audacious, right? Because we had just launched 15 minutes suborbitally. We didn't even get into orbit technically. We skimmed the surface and came back 15 minutes later, landed in the Atlantic Ocean. Yet the president says we're going to go in 9 years and land on the moon, something that's never been done in history. Schedule pressure. Holy mackerel, talking about schedule pressure. We had to transform a section of Florida, if you've ever been to the Kennedy Space Center or not. I say this with affection because I love the place. It's a swamp, right? It is a swamp. There was nothing there except for alligators and some mean snakes. They turned that place within a couple years into the most technologically advanced place in the universe. The biggest buildings in the world, the biggest rockets in the world, and the most advanced machinery and software in the world. They did it fast. The vehicles were coming more and more. We had to meet this goal to get to the moon. With schedule pressure in every situation, every organization faces schedule pressure. Sometimes the more pressure applied, decisions start getting morphed a little bit and twisted. The more pressure placed on us, right, we make decisions that maybe we wouldn't make if we had more time. I'm not putting schedules down. Schedules are important. We need schedules. We'd never launch a rocket if we didn't have one. You'd probably never pump any oil if you didn't have one. Right? So schedules are important, but it's how we handle the pressure especially when things are not going well. It makes a difference of a good day and a bad day. So in this case, we finished through the Gemini program. We're in Apollo in 1967. We've got basically 2.5 years now to get several flights off the ground to get one that lands on the moon. A lot of pressure on the system. Our mission was to launch this capsule. Brand new capsule. It's the first 3-person capsule. Okay, but it kind of felt like the other ones, Mercury and Gemini, not too different, just a little bit bigger, different systems. We got too comfortable with our processes. What we were doing was we loaded the crew on board, and we said we're going to do a plugs-out test, which was a dress rehearsal. The test was labeled a non-hazardous test. Okay, a very similar procedure has been done in Mercury for several flights, Gemini for several flights, and now Apollo. So the launch team and the flight crew on board were all thinking this is non-hazardous. We're going to get on board, we're going to strap in, suit up, we're going to do some comm checks with launch control, work through a dummy countdown, and go home and have dinner. That was the intentions of that. It didn't work out that way. 6:31 p.m., this was the result. A flash fire breaks out in the capsule and consumes the crew alive. This was very, very painful. And there's still some folks left to tell us the story. They were on console that night. Lots of lessons learned came out of this. What's very interesting is when the investigation board went through and talked about it and did their congressional report, Frank Borman and his group coined a phrase. And the phrase was, the team had a failure of imagination. That's a really weird thing to say to engineers. Maybe the folks at Disney World, an hour to the west. But for us, we don't do imagination. What do you mean by that? We had a failure to imagine all different scenarios happening. We were so fast and furious where we were going, we didn't understand certain things. For example, this hatch. This hatch actually opens inward. So when you're in the capsule, it opens inward and down. That's how they get in the capsule, instead of opening outward. Good reason for that. On the second flight of Mercury, Gus Grissom was flying, and the hatch prematurely jettisoned in the Atlantic Ocean. His capsule started filling with water. Gus got out within seconds of his life because his capsule went down 16,000 feet into the Atlantic. How do you fix that? Well, the hatch is never going to blow off again. We're going to have the hatch opening inward. That solves that problem. Unfortunately, we didn't have an imagination. We didn't understand if you had a fire on board the capsule, you're going to have a tremendous amount of pressure increase in the vessel. That pressure increase makes it really hard to push against it when you're opening the hatch inward. It takes a lot longer to do that. We solved a problem in 1961, and it gave us a deadly consequence with another problem in 1967. So sometimes fixing something, please don't have a failure to imagine what the consequences could be. You may not be saving the day down the road. Another thing we didn't imagine, right? Simple things, but simple things get you. We had a pure oxygen environment in the capsule. We've been flying pure oxygen for a lot of years. And there's good reasons to do that. We also been adding Velcro to the capsule. Astronauts love Velcro. That's their best friend. Because when you're floating around and your pen's floating around your checkbook, it's sure nice to stick it there and you don't have to reach behind you or try to find it somewhere. Because zero gravity, everything's floating all over the place. Crews wanted more and more Velcro on board, right? As they're getting used to flying, it's a good reason for that. But now you're introducing an oxidizer with oxygen, you got a fuel source in Velcro. All you needed is a spark, and that's what happened. Spark hit, raging inferno, lost the crew. We had a failure to imagine that. So again, sometimes solving some problems is adding more problems, things to think about. The consequences of not realizing that was the loss of our first crew. So Gus Grissom, Ed White, and Roger Chaffee are lost because of this. We nearly lost the program at that point. It shook it to the ground. This was the first accident NASA's ever had. And we didn't even get off the ground. It wasn't in flight. It was doing a dress rehearsal. So we did the investigation. We learned a lot. We learned a lot of the lessons. I mentioned a couple. There's so many more for a longer conversation on a different day, but we learned so much. We finally got back on the horse. Apollo 17 went up. We went back into Earth orbit, and history told us 1969, Neil and Buzz went to the moon. Everything was very successful, finished out the Apollo program. So we were employing those lessons. We were doing pretty well. Had a little hiccup on Apollo 13, but that's a different story. We'll talk about that another time. But we had our mojo going pretty well. Finish Apollo, get into Skylab, get Apollo Soyuz. We're moving along, start building the space shuttle. 1981 rolls around, and a brand new vehicle, space shuttle, much more complicated vehicle than Saturn V. But we start the space shuttle program off, and we're off to the races. The problem is, schedule pressure popped back up again. The space shuttle was going to do everything. That was advertised to Congress. You're going to launch all the military satellites, all the communication satellites, all the scientific satellites. You're going to launch laboratories in space, and eventually you're going to build a space station. That's a lot on one system. We're going to phase out all the expendable vehicles. All the eggs are in the shuttle basket. Well, it's a great idea, except the space shuttle, as beautiful as it is and capable as it is, it's a hard sucker to launch, I can tell you. It's a lot of work to turn it around. It's a very, very complicated spacecraft. So instead of the 25 to 50 flights, depends on your projections, per year, the first year was 2 flights. Then we had 3 or 4 flights. Right? We weren't getting up to that cadence. So as the missions got backlogged, the payloads start stacking up. Right? And it doesn't make customers too happy. You also have Congress and other folks that you've told them what this vehicle is going to do, and you're not living up to that. So schedule pressure gets placed on the system. You've got to launch more. You've got to launch faster. You've got to get that flight rate up and get the payload manifest down. A lot of good people start making not so good decisions based on that pressure. Lesson learned, all of us can do that. Right? I always say you put enough heat on anybody, anybody's malleable. Right? And just realizing that ourselves, even our best intentions, we cannot even see it happening sometimes to ourselves. But again, enough pressure applied, even titanium will melt at some point. So, enter Challenger. 1986 is going to be a banner year for the space shuttle program, a record year. It got even more complicated because at the end of 1985, Columbia got pushed into 86. So now Columbia squeezes into early January 1986. That puts more pressure on Challenger, which is to fly after that. Okay, so when Columbia got up and got back down, now all eyes are on Challenger. You've got to be, now you're behind 1 flight. You better get this flight up and back because you've got to make up time. More and more pressure gets applied to the system. So Challenger's on the pad, again, January 1986. It's a unique year, and I'll show you some pictures why that was a unique year. The night before launch, and I wish we had more time, but again, you could spend days on this. The Challenger launch decision is unbelievable. When you read, there's books and books written on it, and videos and movies. It's a treasure trove of what to do and what not to do, and how schedule pressure really can hurt things, and budgetary pressure as well, because we do get squeezed by budget, right? And part of the manifest was budget related. Congressional budgets towards the space shuttle program was schedule and budget are always intertwined. Nobody has unlimited checkbook. I've never seen it. Even in the government, we don't have unlimited checkbooks, so that plays a role in everything. Night before, a lot of conversations were being had. There were concerns because the time of year was January. Florida can be chilly in January. Well, this was forecast to be record cold temperatures, something abnormal, right? So we have something introduced. Some of the engineering elements were concerned. Some of the systems weren't tested to the temperatures we expected at launch time. We didn't have that set of data. So it's a gray area now, right? We're not violating launch rules. We don't have launch rules in this case. So the gray area mixes in. So initial conversations from some of the teams, engineering teams, were, we're not comfortable to fly tomorrow. I can't certify my system that it's going to be safe to fly. Well, that wasn't the answer for a lot of management folks because I've got to fly. I got a vehicle on the pad, I got a crew ready to go, I got a manifest to accomplish. You can't prove to me it's not safe to fly. And the conversation, instead of prove it's safe, the team had to prove it's unsafe to fly. All right, so our paradigm starts shifting. Again, pressure was being applied to these folks to make decisions they might not want to make. Here's some comments that were made the night before launch. Right? Take off your engineering hat and put on your management hat. I can assure you that's not a fashion conversation. I was saying get with the program. Come on, folks. You're saying no go. That's not what we want to hear. Look at it through my eyes. You don't realize all the pressures we're facing. You don't realize what this means. This no-go, you don't know what it means. Right? So how many times have we done that, even unintentionally, with body language? Right? And some of these folks, we don't even know if they meant to say that. How many times with our families or our coworkers do we say something just to nudge people? We don't even understand what we're doing or the intention of that, how it's received. Right? Especially if it's leadership telling us this, or bosses, or people that are running contracts. Right? There's a lot on the line. It's like wink, wink. Listen to us. Other comments like this were made. When do you want us to launch? Next April? That's actually pictures at the launch pad with Challenger in the background. Again, I'm not sure who's been in Florida, but I can assure you that is not Chamber of Commerce weather. We don't advertise that. Icicles at the launch pad. Crazy. The box on the right is actually a box we use as test directors to talk to the closeout crew, loading the astronauts on board. You plug your headset into that. We couldn't even plug our headsets into it to talk to the crew. We didn't look around us. We had that failure to imagination came back to get us. Right? This is not typical launch conditions. So when the engineers were saying, I'm not sure in these degrees, these temperatures in the 20s, what it's going to do to this O-ring system, which is in our solid rocket booster joint system, what does that really mean for us? I don't have test data that says they're not going to respond correctly, but I'm concerned they won't. Well, where's the data to prove it won't? Right? You keep getting asked that question for several hours that night, and you have no answer. Offline conversations happen. Team came back and says, now we support launch. And there's a lot behind that story. Okay? But decisions were changed based on pressure. Again, that's also not an open-ended question. They didn't ask you when you want to launch. Get with the program. Nobody said that day, go do this, it's unsafe. Go put the crew at risk. I don't care what you do, just launch tomorrow, doesn't matter what happens. This was all subtle, suggestive, psychological things that we did to get the point across, and it had devastating consequences. The folks were afraid that the O-rings, right, and these are just rubber seals, everybody's got O-rings in their house, right, seals between the booster joints, which keeps in the flame and the hot gas. If those joints don't seal on launch, it's not a good thing. They were afraid that the rubber O-rings would not expand quickly enough during the flexion of launch, and you'd have a leak through of the material. Okay? Here's a picture at T0. You can see the picture with that puff of gray smoke. That's the worst fears being realized. That's the O-ring being burned through and smoke coming out. That's the degradation of the O-ring. So there's a pass-through of the fire and flame inside the booster outside. Interestingly enough, we got lucky. That joint sealed itself within a couple of seconds. So we start rising up, and everything was okay. Unfortunately, wind shear shook the vehicle, and it shook it loose, and the jets start forming again. And you can see the picture on the other side. The jet got bigger and bigger until we lost the crew. So those same things came back to get us. The failure to imagine, schedule pressure, the budgetary pressures, right? Making inappropriate bad decisions, not having the safety, the psychological safety to navigate through this. This really shook the program to its feet, as many folks remember where you were when Challenger happened. People out there still don't forget it. None of us forget it. Many of us saw it live when it happened. So we did what we always do. We said, okay, just like Apollo 1, well, we learned a lot of lessons, but we forgot a lot of those lessons. But we're going to relearn those lessons. So we relearned a lot of the lessons again. We did a major redesign of the vehicle, try to fix all those little fixes that would happen. We fixed the booster joints, we put heaters on, we did all kinds of things technically. We stopped people from working 80-hour work weeks, which they were doing. People were actually sleeping in their offices. And I know folks that tell me they had cots under their desks. And when they finished their shift, it was easier to just sleep under the desk than it was to go home. Right? So this is the pace. So we went back and cleaned a lot of that up, put workplace rules and everything else in place. We learned a lot. And we got back. President Reagan commissioned Endeavor, so we're back to 4 orbiters now. So we got 4 vehicle fleet. Pace picks up all those manifests. We're trying to finish off the manifest that was backloaded after Challenger. We get the call, we have to build a space station. So space station program starts up, and all that pressure starts flooding back again. We got this major international collaboration, multi-elements from around the world, working with tons of different governments. It's a very tight assembly sequence. If you think Tinker Toys and Legos are hard, try building a million-pound space station in orbit. Not so easy. So we had all these elements coming from around the world, and it had to be very choreographed, very, very tight. You couldn't make mistakes. Everything had to be lined up. So that pressure to do that and meet certain core completion dates was essential. We had clocks on our desks, core complete dates. You must meet this milestone. Right? So that pressure kept coming on and coming on. Columbia was heavy. It was the first vehicle, so she was built heavy. And she couldn't get the station in the configuration she was in. So all the other orbiters were taking up the load. Columbia kept getting pushed back. Eventually, Columbia's mission, right, our payload customers weren't so happy. It was a research mission. Columbia had to finally get up, get the mission completed, get back home so we could actually retrofit the vehicle to go up and help the other 3 orbiters finish up space station. So again, schedule was really getting intense for us to take care of that. So now we're entering in the early 2000s, and Columbia's on the launch pad finally after a couple-year delay. Again, focusing on this mission to take care of things. We didn't realize, and I lived through all this, we didn't realize all those things were creeping back into the system. I saw the clocks on my desk. We were cheering the number of days and meeting milestones. Right? I didn't see that either. I didn't see what we were missing. I didn't see the pressure being applied. You took it as a challenge in many cases. Well, we can do this. We're NASA. We can beat that. We'll even meet the date. We'll meet it and we'll beat it. Okay? It's a challenge. We didn't see what was doing to the team and the decisions that we were making, which were not very good, because we had other problems below the surface, and I'll share those in a minute with you. Other problems below the surface that we kept negating and pushing off and rationalizing our decisions based on those. What I want to do is, before we go any further, I want to take, it's about a 5-minute video. I just want to bring us back to 2003. I want you to see Columbia. I want you to meet the STS-107 crew and get a feel for those folks. They were absolutely amazing folks, I can tell you. Incredible Renaissance astronauts. And I want you to meet them, and then we'll come back and talk a little bit more afterwards.
My name is Rick Husband. I'm the commander of STS-107. Whenever we have these type of launch delays, you know, I would say probably initially there might be a bit of a letdown or disappointment, but then we realize that we've been given a gift of more time to prepare. And we're going to be flying a 16-day science mission. We'll be dual shift, round-the-clock operations, doing science in a Space Hab double research module for 16 days. We're really looking forward to it.
Rick talked about the delays a little bit, and I'd have to say from a rookie standpoint, the delays are probably good. I feel that in going through the training flow essentially a second time, a little bit less like a rookie and a little bit more like a veteran.
It's been 6.5 years since I came to NASA, so and I really was hoping that I get to go sooner than this. I got the most excited today when we pulled out of crew quarters in the Astro van and I saw the flashing lights and the police cars and the helicopter following us, and I really felt like a little kid, and I remember getting down to the vehicle thinking I should really be, you know, a lot more serious, a lot more paying attention to detail. But then I thought about how I had worked here for 2 years as an astronaut prior to getting assigned to this mission, and I really know the care and attention that everybody here puts in to getting the shuttle ready and launching it. And when I thought about that, it really let me relax and just kind of enjoy that excitement, and I'm sure it'll be the same and even more launch day.
And And our astronauts coming out now as they are making their way to the astronaut van. Commander Rick Husband, payload specialist Ilan Ramon, pilot William McCool, and mission specialist Michael Anderson, David Brown, Laurel Clark, Colt Nachapa.
Okay, Rick, if there was ever a time to use the phrase, all good things come to people who wait, this is one time. And for you and your crew, best of luck on this mission, and from the many, many people who put this mission together, good luck and Godspeed.
Oh, we appreciate it, Mike. The Lord has blessed us with a beautiful day here, and we're ready to go.
10, 9, 8, 7. We have a go for main engine start. 5, 3, 2, 1. We have booster ignition and liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments.
Houston now controlling the flight of Columbia, the international research mission finally underway.
Roger, roll, Columbia.
What our plan is on the flight to try and capture each of the crew members in progress of doing some of their jobs on orbit with some narration.
Now here we have the red shift and the blue shift all on the mid-deck during our handover before the blue shift goes off duty and the red shift starts their day. And what we do is we gather, we try and pass on what we've learned from the previous shift and what the status of the various payloads is.
And of course, we're getting ready to go home, so we're doing exercise and even doing push-ups in order to be ready to feel good when we get back to Earth. Push-ups seem a little bit easier here for some reason.
Go ahead, Houston.
Yeah, Rick, I guess you've been wondering, but you are go for the deorbit burn. We are going to continue to assess which runway end we prefer, but for now we are happy with the weather at KSC. You are go for the burn.
Houston, here comes SSME high repress.
And we're ready, Willie, no deltas.
Copy, no deltas.
So we're going to leave visors down now.
Hello, I'm just saying, just check your suit.
Banking to the right now, a steep bank of 60 degrees and approaching the west coast of the United States. Columbia speed 16,620 miles per hour.
Columbia, Houston, comm check. Columbia, Houston, comm check. Columbia, Houston, UHF, comm check. Columbia, Houston, UHF, comm check.
So that was a really bad day for us. That's a day that I'll never forget. I was in those rooms working with the teams. I'll never forget them. That's why we're so impassioned. That's our why we do this. It's hard to talk about this. You relive the emotions every time we do, but that's why we do that. We never want anyone else to experience or feel what we went through. So please think of the times that you've had that were not very good and try to use that as your motivating factor to be vigilant, especially in those times where it's hard to be, right? When you're being pressured to move quick, think about those times, and that'll help be your compass again, recentering your why of what you need to do. So, bringing it back a little bit, we'll start with the end result. What happened? It was actually really, really simple. Getting there was not. We'll show that as well. But the end result was really, really simple, right? The problem. Something came off big orange tank, which is basically a big thermos. It's filled with liquid hydrogen, liquid oxygen, right? Hydrogen's 423 below zero, oxygen's 297 degrees below zero, very cold. And if you didn't have insulation on that tank, you'd have basically a big giant ice ball going up. Well, that's not good to do, so we have to insulate it. So that orange tank is covered in insulation and foam. We've been battling that issue for years with foam flaking off the tank on Ascent. Okay? We'll talk more about the foam in a second. So basically, on Ascent, about 82 seconds in, a piece of foam came off the tank and actually hit the left wing of Columbia and caused damage. Okay, very simple, right? Something comes off part A, hits part B, causes a hole. That thermal protection system keeps you alive. The temperature of reentry is 3,000, 3,600 degrees coming back in. Very, very hot. Shuttle's made out of aluminum. Aluminum, 900 degrees, doesn't do too well, right? So that tile, those tiles, 30,000 tiles covering the vehicle and reinforced carbon panels keep the crew nice and cool inside and keep everything good. A breach in that system is not good. That's the basic cause of what happened. Again, getting there is the harder part of the story. So what I want to do is I'm going to show you a video in a second, because it's not always easy seeing these things as they're coming at you, right? And I always say it's so much easier on a Monday morning to tell them what the quarterback should have done on Sunday, right? We can all sit there and go, they should have done that. They should have ran this play. The defense should have done this. But when you're on the field real time making those decisions, it's not so easy. We tell our folks that, right? It's easy to look at one of these presentations and sit back and go, yeah, we should have done. Harder when you're in the game. So having that humility to realize that, important to do. This imagery is actually a video. It's actually an enhanced video. So this is what the initial debris teams looked at the day of launch. We look at every angle of the vehicle and every asset, every single frame to see if anything's out of normal specs, any concern. They saw this video. This video is actually the better version that Kodak helped us with. The first video was even worse, more grainy and fuzzy. I'm showing you the better version because I want you to see, can you tell there's any damage to the vehicle? So if you saw this and had to report to your boss or your team, here's the concern, here's what I see, how would you describe what you see? If you'd run the video. You see the foam coming off the tank up towards the top. Can you see any puncture of the wing? Can you see any damage to the wing? In a second, you're going to see the backside video on the underside and see if you can see something there. Okay, you can see it tumbling. It seems to hit the wing. Can anybody see any damage? Okay, so you can see that thing two different ways, right? You can see, hey, something came off, it could damage it, or I can see, I don't see any damage on that. That's the best evidence we have of a problem, right? I see nothing. That's the problem, we see things so differently, right? It's a good thing, but it's also a challenge. Ever see a TV show or a court TV show, right? Well, lawyers, right, I should say that. I'm sure you have. I'm talking to a kindred audience, right? You can stop the video. If you've ever seen one of those things, I think it's always classic for us to watch, right? It's car A hits car B, car A is in fault. And then the defendant gets up, oh, no. She hit my car, right? Is it he hit her car, she hit his car? How does it work, right? And sometimes they both see the exact same accident, right? Something happened was the truth. How do you get to that truth? Well, no different in engineering than what you guys do in the legal world. We face the same thing over and over again. Now I'll work you through that. When we went to the investigation boards, the inquiries is fascinating. Witness statements were so conflicting all over the map. Professional engineers, leadership, everybody in between, lots of experience, completely different witness statements of what happened during the 16 days of flight, mitigating what they saw in that initial video. Okay, and that led a lot of decisions, what was made and what wasn't done. This is why be so careful, right? Having the humility, how we describe things. Maybe realizing we saw it wrong, right? But we always try to convince each other, right? My school's the best, this is how we do things. Sometimes having the humility of saying, I could be wrong. Tell me why you saw it that way. It's hard to do. This is a lot of simple stuff I'm going to be talking about, but that's the important part of it. First thing we did was get me someone smart. What does this mean? Right? We do that in our business all the time. Get me an expert in that discipline. So we hauled the folks in, thermal protection system. What does this mean? Tell us. We've had different strikes on the vehicles before, but this looks like the biggest one. Get me an expert. Expert opinions, I'd humbly suggest, are just what they are. Right? They're not in stone tablets on a mountaintop. It's opinions. Opinions can be wrong. In our business, we never want to challenge somebody else's opinion. Professional courtesy at times. Sometimes if it's a different discipline, if I work landing gear and somebody else is doing environmental control, I'm not going to ask, I don't know their system or main engines. I'm not going to mess with them, right? So other systems or people have more knowledge. We're not going to challenge people we don't know as much about. That's just baked in our DNA. It's baked into who we are. We don't like to do that. We certainly at NASA don't like to do that. We bring the experts in. That's verbatim. Thank you for your answer. We'll make our decisions based on that. Unfortunately, what we got from this one was the wrong opinions, right? Caused us an accident. I'm not going to go through all these charts, but a couple things just to boil out of it really quick was the initial opinions from the team that saw it said that it's either very unlikely or impossible for foam to come off this tank, hit the leading edge of the wing, and cause a breach in the wing. Experts said that. We didn't have all the test data. You can't always have test data on everything. So all of the years and years and years of tribal knowledge and experience and wisdom and all the suppositions came to the conclusion, we've never had it before, we've had strikes, therefore it can't happen, or very, very unlikely to happen. That set in the mission management team's mind, there's my answer. I don't have to worry about it that much. This is not a safety vehicle and flight crew risk, so I can disposition it in a different pattern. That was essential. Difficult, and also something happened, the debris assessment team, once they start running some modeling and doing some more analysis, they realized, well, maybe something could be wrong here. But the way the system was set up, they didn't have access into that team. So when they start countering some of the suppositions made early, it's like, well, we've already talked about that. The other team's already disqualified that. Okay, that initial opinion was so strong, it anchored the decisions in their minds, and that drove us for 16 days in the wrong direction. I'm going to show you this really quick. This is a video when we start analyzing what happened and really realize what the mechanics were. In other words, how big piece the foam was, what was the angular momentum, what was all the dynamics of that piece, how much energy did it have when it hit the vehicle. When we really start analyzing what that could have been, we replicated some tests. We took reinforced carbon-carbon materials, we took a big foam cannon, and we shot it at the exact speeds we thought we were going to be facing on orbit. I mean, on ascent. I want you to see this video and hear the end if you hear any noises at the end of this video.
We'll fire on 0. 5, 4, 3, 2, 1, 0.
Looks pretty likely that can happen, right? So again, our leading experts said this was either impossible or very unlikely to happen, but yet we proved it was true. Did you hear what was at the end of the video? Did you hear the noises? Gasps? Okay. Those people watching this was the world's leading experts in foam, these materials. I mean, these are smarter than smarter people, right? They were working the problem for 6 months. That's July. This is 6 months after the accident. 6 months of studying the problem and the materials. And they're gasping in disbelief of what actually happened. That shows you how strong decisions and opinions can be set in leadership's mind, or all of our minds. Right? Often it's the first thing we see, boom, locks in, that's the truth. Dangerous to have. It took 6 months in this cannon test to prove it was something different. So there's the hole, there's the smoking gun. We couldn't figure it out for 6 months. Experts, there's lots of things to say about opinions and experts, and I won't go through all of them, right? But well-meaning, lots of things, right? So unconscious bias, we all have unconscious bias. All of us do, right? We all want the person like our team, right? Texas A&M or whatever team you like here, right? That's our best team. That's the best team in the world. Well, it's natural. We all have our influences to do that. We want to get to the right answer, the correct answer. We want to be right to the boss. Sometimes you apply wrong expertise. When we start modeling this, we didn't have the models for reinforced carbon-carbon, the leading edge. We had tile models for all the acreage on the belly. So we didn't have any data, so what do? We said, well, we don't have perfect modeling for that, so we're going to take the other system, and we're going to tweak it, and we're going to bend it and play with the formulas to get something, to give some kind of data to it. We applied the wrong information and got the wrong answer. We talk about anchoring decision makers. When things start coming along the way, people discounted it until this test. People wouldn't even be listened to until that test proved something else can happen. And we like to justify our opinions. We also like things we want to hear. We don't challenge those. Everybody's been to the doctor before, I assume, for annual physical. Right? That's always a fun experience. We look forward to that every year, right? Getting poked and prodded and all the, right? Never a fun experience. Have you ever been to the doctor and gone through all of the blood drawing and all the everything else they do, right? I won't go through all the things they do, but they're not pleasant. And you go through the whole experience, and the doctor finishes up and says, you look great, we'll see you next year. Have you ever challenged that decision from the doctor? If you're like me, you're putting your shirt on in the parking lot. I can't get out of that room fast enough. Get me away from that paper on the table. Get me away from all that stuff. No more everything. Just get me out of here. See you next year, doc. That's all I got to hear. I can tell you if the doctor says, Mike, you may not want to buy too many green bananas. I got all the time in the world. Let's sit down and talk. I don't care what the rest of the day looks like. I don't care how good dinner sounds or smells. I'm not going nowhere. We're going to talk about this. And if I don't like your answer, there's a yellow page. Well, for the old folks, there's yellow pages, right? You go on the internet. There's a lot of doctors in the phone book. And I'm going to keep on looking until I find one that gives me an answer that doesn't say green bananas. Right? We got the answer we wanted. It's basically not going to be a problem for the flight and the crew. We pushed on too quick. So also, please, I humbly suggest, be careful of accepting opinions that sound good for budget, for schedule, for safety, whatever it happens to be. Right? Even our own opinions, be careful of those. They're very attractive, and you can just latch onto them without even realizing what we're doing. I boil it down. I'm a pretty simple guy. I call it the DNA thing. This is simple stuff. Right? We're all come to the table with this stuff. All these biases are kind of cooked into us. All the amazing things that make us diverse and different, right? It's also a frailty that's baked into our DNA, knowing that we can't really change that too much. Thousands of years of human history, right? Titanic, all these stories, we can go back and talk about accidents throughout history. Right? But at least coming to the table saying, I'm flawed. My decision-making could be flawed. And I'm going to be humble. I'm going to be listening. I'm going to be respectful. I'm going to try my best not to add to the possibilities of having mistakes. Here's a little cartoon you can take a look at. In our world, data is king. Right? We love it. Ones and zeros, man, you want to make an engineer happy or a scientist, just give them a lot of ones and zeros, and man, just turn them loose. They'll be as happy as a clam, don't even need a TV set, just they go for it. I remember also growing up in the shuttle ranks as a young engineer, and we had a lot of slogans. And one of the slogans from the chief engineer's office was, trust in God, all others bring data. Okay? That was a pretty cool slogan, right? I interpreted that, and many interpreted it as, you better not come in my office unless you've got your I's dotted and T's crossed. You better come with a lot of papers and be able to back yourself up. Intentionally, that was a good thing. You're going to know what you're going to become the best you can be. You're going to come prepared, and you're going to be ready for good conversations. Unintentionally, what that taught us was, you're not coming to see me unless you've got everything perfectly wrapped up. Well, in our business, you don't. Right? You got the ones and the zeros. You got the 100% here and the 0%. We live in a gray area. We got our launch commit criteria. We got all those easy things, but there's so much in between. That's what the tribal knowledge I speak of. Right? And often you have to go forward and say, I think this is a problem. I can't prove it. Or, here's some data to support it. Here's some other things. I can tell you, if you have bad data, you're going to make bad decisions. And you just saw a second ago with Columbia, we had bad data, we made bad decisions. If we had accepted we didn't have the right data, who knows what would have happened? Maybe we would have ran some of those tests on flight day 1 or 2 or 3. Maybe we had better answers for the crew on orbit, but we didn't. We wasted 16 days not getting to the solution. If there was one, we'll never know. But we never gave ourselves a chance to get the right solution. 3 best words you can use sometimes: I don't know. I also characterize to the young engineers, please do not use this on every occasion. This is not your get out of jail card in Monopoly, right? This will not, this will end a career quicker if you use it every single day. But sparingly when you need to use it, use I don't know. And if we're a boss or a leader, accept that answer sometimes. Nobody likes that. I mean, I worked a lot of shuttle launch countdowns, and the launch director sat right behind me. When I had to say go or no, I never want to say, I don't know, Mike, if we're ready to go or not. That was not a good place. I never practiced that line. Never wanted to be that person. I always want to have, yes, sir, that's boom, 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 boom. And I work my best at that, but sometimes I don't know is the answer. And hopefully he would give me the space to say, you know what, then let's go figure it out together. With pressure, sometimes that doesn't happen. I won't go through all these things, but basically, cut and pasting sections out of each of the accident reports. You could paste things out of Apollo 1, Apollo 13, Challenger, and Columbia. Just change a couple names here and there, change foam for O-rings, for hatch, for oxygen, hydrogen, tile, and they fit. We get really good at learning, and then we forget. And we learn, we forget. We learn, we forget. That's why we're so impassioned now. We don't want to lose another crew. We're flying all brand new vehicles. We're getting ready to launch with the partnership with SpaceX, the largest rocket in the world ever, Starship, 400 feet tall, almost 20 million pounds of thrust, twice power of the Saturn V moon rocket. Massive rockets. We don't want to make mistakes. We don't want to lose crews. There's a lot on the line. So we don't want to forget. That's why we're doing this. This is a comment that was made by the investigation board. This hurt us. These comments really hit us because we had the foam as the villain. I worked, a lot of my career on board Columbia, working Columbia. We loved the crew. We knew the crew very personally. We've done anything in the world to get Columbia and the crew back home. So when the investigation board says the foam is only half the villain, you're equally responsible, that kicked us right in the stomach. Okay, it's something we can't forget. We're just as fault to blame for the systems that we lead and the things that we do. And they talked about culture. Our culture wasn't supporting what it should have been. That culture eroded after Apollo, eroded after Challenger. And we're trying really hard not to let it erode after Columbia right now. Simple problem, right? Foam coming off a tank. Part comes off, hits, causes a hole. A little harder getting to that and figuring out the problem. And the consequences. Hurts to look at these pictures. We let them down. And before launch, we give them briefings. The vehicle's ready. We'll see you home in 2 weeks. We didn't deliver. We can't let that happen again. And this is Columbia today. So as I get ready to finish up the first part, and I'm going to entertain some Q&A in a second, I just want to go through this. This is a chart I have a lot of fun with because it's not the rocket science, it's the hard part. All right, everything, oh, it's so complicated what you do. It must be difficult and all this stuff, and that's why you make mistakes. It's honestly not. We got the physics figured out pretty well. We got the chemistry figured out. I'm not a math guy, honestly, but we got smart folks for the math. We got the computer science folks, aerothermal, all that. That's not where we're tripping up. We're tripping up on the stuff that Grandma taught us. This is simple stuff. This is where we're making our mistakes. Right? So we focus on, the quadratic form. It's not about the quadratic form. This is about this. Things like communication. We're stressing our folks, you've got to communicate effectively. It's hard to do in this world because all we do is communicate. I don't know about you folks, but man, all I'm doing is I'm texting, I'm Snapchat, I'm just, there's 10,000 things I'm not even cool enough to understand what they are. But these people are doing it, right? We're sending all these messages. I found myself even emailing the next cubicle over instead of getting up. Right? My office phone didn't even, it's got like this much dust on it. I haven't even picked it up in years to call somebody. That's just the world we're in. I'm not condemning it. There's a lot of great advancements. Virtual is amazing in many ways. But being mindful that effective communication is important. Having the face-to-face like you're doing today, really important. So kudos on that. And even if it's video, talking to each other, getting to know each other, that positive calm back and forth, essential. You'll see in the CABE report for Columbia, the accident report, so many times where, like I said, the witness statements are messed up. I didn't understand the assessment. I didn't know you want me to do something with that information. People actually said that. I know you sent that to me, but I didn't know I was supposed to do something with it. Right? We didn't take the follow-up phone call. Or follow-up, do you understand what I'm saying? Do we understand each other? Just because I send it to you doesn't mean I understand what to do with that. Right? And sometimes we just shovel stuff off and multitask like bananas. Right? Are we on the same page? Vigilance, that's probably number one, being vigilant. You're doing that today, and congratulations on that again. Being vigilant, hearing the stories, talking the stories over and over again, what happened in your industry, in your offices. Okay, even if you said it for the 15th time, that's okay. Make it 16, 17, 18. It's okay. That vigilance gets it back in your mind because those stories fade and erode over time, and the effectiveness fades as well. Normalization of deviance. That's just NASA's fancy way of saying deviance that creeps into a system change over time that shouldn't happen. This one has been critical every time it's brought us down. Getting used to O-rings. We had O-rings problems since the first flights. It wasn't the first time on Challenger. We had microscopic degradation on the O-rings from most every flight. Some flights more severe than others. So it wasn't the first time, but we thought we understood it more. We got used to that and got conditioned to expect that. In foam in my era, I can tell you, I got used to foam myself coming off the external tank. As a matter of fact, I would go out to the runway after landings, get the crew off, and you look at the belly of the ships, and you see the tiles, and you'd see ding marks in all the tiles. And I remember thinking on certain flights where there was less dings and marks on them, well, that's weird. Why is there less damage on this flight? That's bizarre. There should be more damage. No. Right? The requirements for the shuttle was nothing should come off and hit the thermal protection system. That was our requirements in the 70s and early 80s. Yet we got so conditioned to expect that, our paradigm shift 100%, deviance creeped in. We're sharing that strongly now with SpaceX and all the different companies, saying, as you're bringing new people in, be careful, you know what should be. When I came in, I never saw Columbia brand new. I wasn't there in 81. When I saw a shuttle for the first time, it had damage and marks and all kinds of wear and tear from a pretty stressful environment up there, right? So I was used to that. That was my normal. So you think about when you're hiring people coming in, or maybe you're the new person, well, in a couple of years, you're going to see something that's maybe not right. But that's going to be their normal. That's what it should be. Please never forget what your steady state is and what it should be like. Observing reality, just basically, sometimes you got to admit hard things to yourself and your leadership. Not easy to do, but we have to do it. Relationships. In our business, and I imagine in yours as well, relationships are everything. Having each other's backs and trust is everything. If you don't know each other, if you don't trust each other, if you don't have those things built, something's going to break down. I remember sitting in the fire room, and half the time it got me out of trouble was just listening on the net with 16 different voices in my head, different channels, knowing the people, knowing their voice, telling whose voice it was, what tone of voice it was. Bob sounds a little strange with that. He sounds a little hyper. His voice sounds a little different key. That's not normal for him. He never does that. All those little nuances will save the day. That's relationships. Time is of the essence. Good case, Apollo 13. Right? You go back and watch the movie or whatever, it's pretty accurate, right? What happened? The problem happened, man, everybody jumped on the problem, they tackled it. And they pulled a rabbit out of the hat. I call it the Gilligan's Island episode. right? They solved a crazy thing using crazy things on board, but they did it. They used every single second. We didn't do that with Columbia. We saw the videos and then we put it in the chain. Oh, this process board will do this engineering board will do this. And this big sausage making machine started being put together. And oh, this board, we'll see it tomorrow. This will happen here. And we relied on this beautiful flow charts. But we forgot the flow charts are just people making actions and decisions. And we didn't get the sausage made at the other end of the machine right. Important. And we didn't use every second effectively. And maybe we could have done something. That's another question. But we didn't give ourselves time to win. 2 ears, 1 mouth, right? That's Judge Judy, actually, I took that from, so your legal profession. Simple, right? This is simple stuff. I'm not teaching you rocket science here. We don't listen very much. We didn't listen to Challenger. The vehicles were screaming before launch. 2 flights before Columbia, we actually had foam come off the orbiter, or come off the tank, hit a steel solid rocket booster and put a dent in the steel. That's not a warning sign. I don't know what it is. But we dispositioned it, didn't hit the orbiter, right? The stream is a different stream. It's not going to hit the orbiter side. We discounted it. Not good. Part of uncertainty, tools for success. After the accident, man, we did a lot of things. We put cameras on the vehicle. We put telescoping booms on orbit. We brought the folks up to the space station. We had the space station. We'd flip the orbiter upside down, have the space station folks take pictures of everything. We did everything. We had launch on need capability, rescue flight capabilities. You could stay on station for 6 months. We had all these great things. We figured out what to do in an emergency after the accident. All great things, but we didn't do them before the accident. So I invite humbly to say to you, what can you do today on your systems, on your rigs, on your drilling systems, whatever you do? What can you do today that will save the day in the future? Not waiting for an accident board to tell you some very simple things you can do to save the day. Complacency, we all know about complacency. We got too complacent. The last thing is diversity. And I'm not going to do the HR diversity class, so please don't worry about that. This is diversity of thought and diversity of dissenting opinion. Through our decisions, the folks that said, we're not ready to launch in these temperatures, that was not an accepted position. That wasn't the decision they wanted. A diverse opinion wasn't thought. So we stress our folks, you have to let that outside thinking happen. When you do it like in Apollo 13, magic happens, right? They were told, everything's on the table, you just get the crew home. Ingenious people came up with an ingenious design. So it's easy to start putting that. We're finding now, in certain studies, if you read them, 25% of the American workforce is afraid to say certain things at work. They're being afraid of being canceled at work. Okay, and that's people that admit to it. So if a quarter of the workforce is afraid of being canceled for their opinions at work, how are they going to respond to going against what 60% of the office says? Or what the decision? Who's going to be that lone voice to stand up and say, I don't feel comfortable with that? And I won't get into all the reasons for that. I'll let a sociologist figure that out. But just knowing that most people, or a lot of people are coming to work, I should say, not comfortable expressing all their true feelings, makes us want to make it a safe environment so we can do so. So with that, I'm going to stop. I got one thing at the end for you after Q&A, but I want to stop for a while and just be able to answer any questions you have. Anything's on the table. If I don't know the answer, I'm going to ask Robin to have her answer it for me. But anything else, I'd be happy to entertain. So, and I can be here as long as you have questions. So my plane's like at 8 o'clock. Yes, sir.
Mike, thanks for your comments and the presentation. Oh, thank you. I really appreciate it. I think that if I understood your comments, you emphasize the significance of what we call here human organizational behavior and performance. But in light of the fact that the space shuttle system was such a complex piece of machinery and engineering, can you comment a little bit about complex systems thinking and complexity theory and how that played into your investigation? Thank you.
Yeah, no, my pleasure. Good question. And you said it right up front. The shuttle was so complex. A couple different angles I can answer that question from. One of the things that got us, it was so complex, we were so compartmentalized. Right? I mean, it was so complicated. We had systems. This system didn't even know what this system was doing. Right? We had so much broken up complexity of the vehicle. A lot of folks didn't understand other parts of it or how they interplayed with each other. One of the jobs that I had later on was integration engineering, so we'd work with all the different systems on board the vehicles and ground systems, launchpad and all that. And it was just amazing how many folks didn't understand what else was happening or how their system impacted somebody else. Very, very difficult, right? So we tried later on to get some people classes and teach them other different systems and give them a feeling of how big the complex the system was in decision making. We found a problem with that with our leadership. Because in our case, and I hope I'm getting to the answer of your question, there's different ways to answer it. We went through a big push to try to make our engineering understand who your audience is, who you're talking to. We would go through launch readiness reviews, flight readiness reviews, and everybody would want to dish up what was right or wrong with their system. Well, we had senior leadership in the room. We even had our administrator. They didn't probably understand 90% of what was being said. They didn't have a clue. And it's no fault of them. It wasn't that they weren't sharp people, but it was people who were talking in different languages, their own systems, in a very complex way to people that were not in the technical trenches. So they were trying to make decisions at a high level, should we launch or not at the end, but even other engineering decisions. And they were hearing languages that they didn't understand. So we kept trying to train folks, you need to break down the complexity. You need to communicate effectively in a way that they're going to be able to make decisions. So we had a very hard time with that over time. You know, some leaders had more technical knowledge than others, but that wasn't their job. The administrator's job is not to get in there and start playing with circuit boards. He's trying to say, you know, if I have to go and tell the president, can we launch or not, or we had an accident, they have to explain the launch decisions. They're not in there saying, yeah, try to jumper that wire. So we faced that a lot with shuttle. Very complex, more systems, more people, more centers involved. We had multiple centers around the country, multiple vendors around the country. Who's doing what, who knows what. Apollo 13 is another classic example. We had actually things happening at manufacturing centers. The tank that exploded in Apollo 13, there was actually issues on manufacture, and a dropping of a tank at a different center caused part of the problem later on. Different specs on voltages and testing voltages got us. So we try to get into more of an integration format, let people know what's going on, share certain levels so we communicate across disciplines. Does that kind of help touch a little bit about it? Okay, thank you. Yes, ma'am.
Since you're partnering with SpaceX now, I'm curious how you're working on the solution, because it's government talking to private industry, and how that's working out. Because didn't they just have one that blew up on the pad?
A little off the pad, but yeah.
Yeah.
No, great question. So yeah, we've been going through a lot of change, right? We went through how many years, decades and decades of NASA launches everything. Now we've got this hybrid of commercial being involved in it, so it's a very interesting dynamic. Initially, it was, you're over there, I'm over here. You know, some views were the commercials coming in, kind of the gunslingers kind of moving fast and loose, a perception. Perhaps on the other side, NASA's kind of stuck in their ways, right? This government bureaucracy is kind of stuck. So that was kind of general entrenched feelings in some capacity. Over time, a really nice thing has happened. Those have broken down, because the truth is in the middle somewhere. We've learned a lot from commercial space and some of the new ways of thinking. And we do things now and improve things that we never would have done before. The way we load vehicles with propellant, we thought they were crazy when they proposed some of these things. But we've learned different ways to do things, more efficient, faster, saves money. So we're learning from them. They've also learned that we're not just here to say no, right? But we've got 60, 70 years of reasons why we do certain things. So I think we've learned from them, they've learned from us. I think a really nice partnership is happening. They think differently, their test philosophy is different. So I can't speak for SpaceX, but in generalities, right? They test a failure. So when they test their rockets, it could be, okay, if it blows up, there's nobody on it. They're testing it. They're going to learn a lot. They're going to come back and make it even better. It was kind of like NASA back in the early 50s. If you see the early 50s and through 50s, early 60s, there was one after another, just boom, kaboom, kaboom, and they were dialing it in. Right? And eventually we got the cadence, we figured it out. SpaceX did a very similar thing. They were trying to figure out how to land a rocket. I thought that was crazy. Landing a rocket, how do you land a rocket? Right? Especially on a barge in the middle of the ocean. You gotta be crazy, what are you talking about? Right? And kaboom, 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 all of a sudden now they've stuck with 180 landings, I think, on a barge. So they tested that philosophy. That's their modus, more their modus. Starship had one flight, got up a certain degree, now they're coming back, and they're back on the pad with a brand new vehicle, ready to fly it again, which is incredible. The pace is incredible. We're ingrained a lot. We're working very closely with them. We have a commercial crew program. If NASA astronauts are on board, we are at every meeting. We are deeply involved if NASA astronauts are flying on SpaceX rockets or anybody else's rockets, or if our payloads are on board. If they're commercial, customers we can't contractually, right? You guys understand that part? So we ingrain as much as we can to help as much as we can. So I think it's really going good. They're helping us grow, we're helping them. But just we see things sometimes a little bit different, how fast we move. Thanks for the question.
We have a question on teams. Can you speak about how leadership should react and when discussions happen and difficult information is presented?
How they should act when different information is presented? Well, there's a lot there. Good question. I think one, just come open-minded is the opening gate, right? Listen to all points of view. You know, try to realize that we all have those biases built in, right? And kind of try to separate. It's hard, right? Because we're all in our mind. You got to separate and say, tell me. And try not to have any preconceived notions or biases. Extremely hard to do. I think if you come to the table with that, that helps. I think if you come with the sincerity that I'm here to listen, and you're listening to me, that makes a difference. Right? So if we already know the boss is already going to be sitting there going like, yeah, whatever, yeah, tell me about it, right? Or reading the magazine while you're talking to him, who's going to go in the office and talk to the boss? But if the boss is actually has that environment, I'm listening to you. I may not agree with you. I may not do what you want to do, but I'm going to give you the respect and the time and the consideration. People are going to come forward and talk. You know, they will walk in the walk scenario. I think that's essential. We've had different examples in our leadership like that. And I can tell you the results of that. Right? So I think being open-minded for different points of view, even if they're not ones that you want, or it's going to cost you a lot of money, right? Or cost you your job, perhaps, in your mind. And I think having that safe space is absolutely essential. It really is. It's amazing. I'll see people shut down and say, well, they're never going to listen to me. Well, who's going to go do that? You know, we all got mortgages to pay. Right? We all think we're altruistic. We're going to be, well, we're people. You all got families to support. You got mortgages to pay. We got a reputation to think about. We're people. Right? You all got that baked in our heads. So who's going to put that on the line? You know, if you know something bad's going to happen, sure you will. But if you don't, you know, if they say it's unlikely or impossible for the foam to come damage, how much are you going to push it up the chain? We had some people pushing up the chain. I want to get photos. Some people are pushing really hard to get DoD assets on orbit to image Columbia. And they were shut down at different levels. Those people today tell me they wish they had gone above, way above and beyond to make that happen. Right? But when your boss's boss says no, and the teams, the experts are saying that's very unlikely or not going to happen, are you going to put your reputation or really anger your boss's boss? Right? But if your gut tells you, or you believe it, that's where that why comes in. That's when you have to go, you know what? I'm going to go do this. And the relationships come in handy because it's scary to go alone. So if I have to go see the CEO or somebody, right, and my knees are knocking, well, if I got a few buddies with me or my team with me, it feels a little safer. Those relationships, that's where the relationships come in to help support each other. So it's easier to walk in that office and say, hey, boss, or Mr. Chairman, here's the problem. Doesn't mean you're all not going to get in trouble, right? But at least it's a little safer feeling. I don't want to get any fired here, so I'm not going to try to give you any direct advice. I'll get a call next week and say, you got me fired, what'd you do? But that's just a couple initial thoughts I have on that. Thank you. Any other questions? Yes, sir. We can't time.
Hi, good afternoon.
Good afternoon.
Given that NASA is a governmental organization and I suppose appointment holders will rotate through different functions, and the fact that from time to time NASA puts different mission teams together comprising different people, how does the organization ensure or try its best to make sure that these very important and pertinent lessons are passed down from team to team and through time? Is there like a framework in place or best practices being set up? And I'm sure we would be keen to learn from that.
Yeah, no, thank you. Hard to do, right? I mean, you have seismic events like losing the space shuttle program, you just lose them, right? We lost that many people. In normal times where you just have attrition, retirements, you can pass the knowledge on much easier, right? You have time to go do that. Our business is hard too because we serve at the pleasure of the president in the executive branch. So we get a direction of what we're going to go do. You know, John F. Kennedy, you will go to the moon. You know, different days in the 80s, you will go build a space station. You know, 2017, you're going to go back to the moon. So we get these big swings of where we're going to go. That's our direction. So we have to respond to different administrations and different congressional bosses that say, hey, we're going to fund you to go do this. So there's some challenge in that. And that's not only big programs, but also planetary programs and other missions that, you know, we support climate this, we support missions to Pluto, we support this. So we're trying to always respond to where the folks that write the checks are directing us to go. That's a challenge, to keep programs viable and safe so we're not pinching pennies too much. With the people, we try to do that too. We really try to do a lot of in-house teaching and briefing and post-test briefing, simulation. We try to do that over and over again. Why this happened, why that, you know, do green card sims. I used to be on the sim team, ran the sim team for years. You know, why we run simulations and run through scenarios over and over again, trying to share that knowledge continuously and reinforcing it and reinforcing the philosophy of decision making, continuous. And it's hard. You know, we had a hard time, I ran the sim. It's hard when you're processing, doing your day job, to find extra time to go run through all these scenarios and reinforce that. It was very hard to get all it in. Some groups did more than others. Some bosses felt it was more important than others. And it doesn't have to be super, like, you know, fire up a whole simulation center, do that. It could just be conversations and staff meetings. Let's talk about it. You know, some of the senior people have been through experiences. Tell us, how did you get in that fix? What happened to that oil rig? What happened to that drilling situation? What happened to that contract? How did this thing fall through? How did we get sued? Whatever, right? And work through the mechanics and having that. And it's amazing when we start pushing that more and more after Columbia especially, people start offering more. When people really felt, back to your question, people felt comfortable. You really want to hear what I have to say? It means something? People were offering more information. And sometimes more stuff that was inside them they were afraid to say before they felt safe doing that. And leadership enforced it. I remember after Columbia, we had a lot of people try different things. Shuttle program leadership would have meetings, and they would get us in the room, and we'd have our technical discussion for God knows how many hours, right? It felt like 3 days in a row. We'd have these long discussions, and at the end of it, a decision was made. And the boss would sit there, and it's like, nobody's leaving. I want somebody to disagree with me. And I want a really good argument why all of us are wrong. It's like, what? And we're watching the clock going, oh, I haven't eaten in 16 hours. I want to go home. That's the last thing I agree with you, boss. Nope. I disagree, and it better not just be something, so you better really be serious. And I want a robust discussion on that discussion and why you disagree with everything everybody disagreed to. Okay, and sometimes it was harder to come up with a disagreement factor, but there's always a contrary opinion. And it reinforced us, I mean what I'm saying. I want the contrary opinion. I'm not just saying that, but we're going to sit here. In some meetings, we sat there for a long time. The first few, we kind of figured out afterwards, we better be ready to be challenging ourselves. But the first couple, we didn't expect that. We all sat there looking at each other like, oh my God, please somebody come up with something. My stomach's growling. You know, but it built that culture, reinforced that culture. It's hard to do. It's that vigilance every day. Did it last forever? Not in every case, no. You know, it's things you remember after the accident. Man, you are just crystal clear. It's like seeing an accident on the highway, right? Everybody's 10 and 2, driving like this. Right? And then a few miles down the road, all of a sudden, you relax your shoulders, and one arm comes off, and a couple more down the road, you got to loosen that. 5 more miles down the road, you pick the hamburger back up that fell on the floor, you know, and then 20 miles down the road, you're driving with 1 foot and shaving. You know, just, we get used to that. Another question? Yeah.
I believe. Can you speak about the planned launch of Artemis II and the US's return to manned spaceflight?
Artemis II return to spaceflight. I like that question. It's an exciting time. I mean, NASA, it's really a cool time to be at NASA. there's questions with commercial space and everything. It is a really, really cool time. We have a lot of things going. There's a lot of things happening that you don't even hear about. We have all these different centers that do all kinds of research. But we have cool stuff. We have landers on Mars. We have a helicopter on Mars now, which is pretty neat to watch a helicopter fly on a planet that has very little air. I mean, try to think of that. Helicopters need air to lift. Pretty cool helicopter flying on Mars. Lots of different things. So Artemis was kind of given the go-ahead in 2017. You're going back to the moon. Very exciting. So we've got a government program, Space Launch System, launching crew. SpaceX is a big player in that, launching Starship. Starship is that massive rocket I was talking about, the 400-foot behemoth. Going to launch landing systems that go to the moon. So it's a really exciting time. There's a lot of things happening. Not only robotic exploration around the solar system, but Artemis is going to get us back to the moon. We're going to go to the South Pole. So the initial flights of Apollo, we landed more of the equatorial regions of the moon. Lots of good reasons for that, a little easier in some cases, a little more challenging to land in different areas of the moon. But we discovered through robotic missions that there's likely water in the form of water ice in the polar regions, which is pretty cool because if you engineer the water, you can come up with hydrogen and oxygen, and that's fuel to launch back off the moon. So you not only have water and stuff, commodities to drink, but you also have energy resources to launch and to use. So we're going to go and explore that. And Artemis, and really the purpose of Artemis and go back to the moon is learning what to do to go further. Again, the old story of, you got to go camping in your backyard when you're a kid before you go out to the Rockies and go do it. So our goal is to go to Mars and do that. We can't go there today. It's really, really hard. I wish we could, but we can't. The technology, keeping a crew alive and doing the mission is just not in our scope right now. But if we learn on the moon and get sustainable on the moon, which is 3 days away, we can get really good at it. So Artemis is trying to do that and hopefully transition to the moon. With commercial space, it's interesting because commercial is helping us, but SpaceX has already stated their goal is to go to Mars quick. So how we work together in the next several years is going to be really fascinating to see how we work and who goes where, how we do it. The cool things are going somewhere and somewhere cool. So that's what we're excited about.
What's NASA doing to eliminate unconscious bias and promote diversity of inclusion internally and with its suppliers?
We're doing a lot of training. We have a lot of training, mandatory training on conscious bias, psychological safety. We keep thumping that over and over again. We have speakers come in. We have a lot of emphasis put on it, not just safety day every year. We keep doing it over and over again. Some bosses will sit down and do role playing in meetings. Take a few minutes out of a meeting and do role playing. What if this, or building scenarios to kind of flush out the biases, or you can see your own biases. We're doing a lot of that vigilant training now, honestly. It's really become important for us because we've realized in examining these, we had a lot of bias baked in the cake. Diversity also is something we're pushing hard. Of course, all the, like I said, the HR legal diversities. But we're really trying to get people to understand this, and this program is one of the shining examples, I think, of that, is getting people to really realize why diversity of thought is important. And as much as we think we are, data shows at a national level we're not, right? People are being more afraid of expressing their opinions. So, we always say we have the gates of the Kennedy Space Center. It feels like a microcosm, a bubble. We live in this very unique environment. But you drive through the gates in the morning, so you get your whole experience on the outside. You come in, well, you have all that you bring into you. How are you going to process things? Right? So if you have your biases on the outside, or if you see people getting fired because of their opinions or thoughts or their positions, how are you going to react in the workplace? Any different? That's only a physical gate. You're not going to change your personality. So we realize our folks coming in may not be maybe as willing as we hope they are to express their feelings based on national polling and based on different things. Okay, so again, that's something we're really, really worried about. And we see it in meetings. Sometimes you see anybody disagreeing. Yeah, they look. Okay, nobody puts their hand up. Well, my hand's kind of, right? It's not easy. If anybody's doing it, it's not easy for me. Who wants to be that person when the spotlight goes? Okay. Last question.
You talked about the phrase failure of imagination. Do you think it's possible to imagine or come up with all possible scenarios? If not, how can we best tackle the situations arising up and the unknowns, which could be part of all the projects?
Yeah, absolutely not. There's no way to imagine all scenarios. My God, I don't know how your head had to be this big, right? Einstein would have probably a hard time. Like I said, there's in our business, I can't speak in your business very well, but our business, we have books of launch commit criteria. I can show you books of, binders beyond binders, volumes of stuff of what to do when, right? If this temperature goes here in this flow chart, you can launch, or you can do this, or do this. I love those. We used to love those as test directors because that was our, our cheat sheet, so to speak. Oh, the reporting 26.6 PSI in this, what does that mean? Here's my answer. Well, you can't write up every scenario because it's limitless. So instead of trying to do that, I think if you build, I humbly suggest if you build a culture to recognize the biases, to encourage dissenting opinion, to have the diversity of thought, then when you have those gray areas, and you're going to always have those gray areas, you're at least going to work together to get through them. Because we didn't do that with Challenger. Show me a launch commit criteria that says you can't launch in 28-degree temperatures. It's not on the sheet. I guess we can launch. Right? There's a little more to it. But that's a pretty strong argument. Show me the requirement you can't launch. Something may happen. Well, how? Where? Show me. Right? So again, if you have that culture, if somebody says, we don't have that data, this is a great set of data, but I don't think we're right, and it's an open environment and people feel comfortable sharing in a safe space to express that, well, maybe you say, well, let's go do some tests on that. Let's go talk about that. Right? And engineers and scientists, I can speak from our world, and again, I can't speak from the legal profession as well, but from our world, we live a lot of ones and zeros, and you want absolutes. It's this or this. And that's not the world we really live in. Right? So just being mindful of that and not trying to gravitate towards, oh, geez, I can grab something close. It's something we battle, but yeah, we can't. If we think we have everything covered, we're missing the whole ball on that one. So with that one being the last, I've got one last thing to share with you. But thank you for those questions. Those are really good. This last thing, I just want to bring you back one more time to the why. It's really important because I keep stressing it. That's going to, again, be your compass. And I've said it 3 or 4 times, but I really, truly believe that. That's helped me a lot of times. When I'm in a hard decision, I have to go and talk to a leader or talk to somebody about something difficult. I know people that pin pictures of the crew in their cubicles or pictures of Challenger or mission patches. Just those memories of saying, hey, I'm not going to forget. I'm going to put that into the equation so I don't forget the consequences. It's easy to do that. This is something that we created. I actually had the honor with my nephew, who's a songwriter in Nashville. So he and I wrote this song together. And we had a music video produced for it. And it's called 16 Minutes from Home. And in Columbia's case, Columbia was coming back from reentry. And Columbia, when we lost Columbia and the crew, it was exactly 16 minutes from touchdown is when we lost the crew. So we wrote this song in honor of the crew. So if we could just play this, I'd like to share it with you.
How can we find what's been lost? Retrace steps, find out the cause. Over and over, what went wrong? Just remember, stand tall, be strong. When you're just 16 minutes from home, know with us you are never alone. We will always remember the ones lost just 16 minutes from home. from home, taking steps into the unknown, but all that we've learned is what they had shown. Maybe the stars will guide them home, and the path forever lit will again be flown. When you're just 16 minutes from home, know with us you are never alone. And we will always remember the ones lost just 16 minutes from home. Heroes alive with the strength to believe, you set sail for the stars where you dreamed us to be. They thought you were lost just to find out the truth. Headed straight for the heart on an infinite route. We know that you're gone, but your dream it lives on through the hearts of the ones who were there all along. And we know, even though you are just down the road, at last you are truly home. When you're just 16 minutes from home, no, with us you are never alone. And we will always remember the ones lost just when you're just 16 minutes from home. No, with us you are never alone. We will always remember the ones lost just 16 minutes from home. You are home. At last you are truly home.
So with that, I want to say thank you so much for taking the time today, thanking the leadership that brought this forward. I appreciate that. It's an honor to be here. Again, thank you for all that you do, and hopefully this plays a little part into helping your mission success for not only the safety, but the success of your organization and your company. So again, thank you so much.
Ignition sequence starts. 6, 5,